So we're continuing with the AP review for multiple choice, for derivatives for our second unit. So for number 11, this is one of those problems where it's chain rule, but this is a nested chain rule here, which means that we have more than two functions to worry about. There's going to be three functions here. But we first have to make sure we write it in the form that will be helpful to us. Sometimes we don't fully see the impact of this exponent in this form. So we want to, whenever we see an exponent kind of written in this form, especially with trig functions, we want to rewrite it. We want to write it so we can visually see the three different parts that we have to involve when we find the derivative. So the first thing we do is let's rewrite this problem. It means the same thing, but visually I think it's more helpful. Let's put that 2, that squared, outside the entire expression. I'm going to use brackets. So I think this helps us see the three different parts that we have to deal with. So chain rule, there's the outer portion, the most outside function, which is the bracket or parentheses squared. And then the next term in is that tangent of parentheses. So we got to worry about that as the inside function. And then the innermost function is what's inside the last set of parentheses, which is phi theta. So we're going to take the outside derivative using power rule, tangent's derivative using trig rule, and then the inner derivative using power rule. Okay. All right, let's do the outside portion first. So parentheses squared becomes 2 parentheses or bracket to the first power, and then we fill in with what's inside the bracket. No changes there. Times, now we move on to tangent's derivative. So tangent's derivative is secant squared parentheses, and then we fill that parentheses with the inner function because we're not ready for that yet. And then times the innermost function, so phi theta's derivative is just going to be 5. Okay, so there's our derivative. We're just going to clean this up a bit. Let's push all the coefficients out in front. 2 times 5 is 10. 10 tangent of phi theta, secant squared phi theta. Answer choice C. All right, 58. These are all kind of variations of product, chain, and maybe quotient rule. We just have to kind of fit it into these notations here. So our B function is represented as defined as f times g. So if I want to find b prime of 2, I first have to figure out what b prime of x is in terms of f and g. And f and g multiplied together, we got to go through product rules. So f prime times g plus f g prime. So once we have our slope formula, we can now plug in our specific x value to figure out the slope. So replace every x value with 2. And now we're going to use the chart to pull the values that we need. So f prime of 2 is going to be 3 times g of 2. So g of 2 is 1. Okay. Plus f of 2. So f of 2 is 5. Times g prime of 2. G prime of 2 is negative 2. Okay, so now we're down to numeric values. Multiply those together. 3 minus 10, negative 7. Okay, 62. M of x is f of g of x. We need to recognize this as this is not product rule. This is chain rule. This g function is inside that f function. So let's we're going to specify what chain rule is for this problem. Chain rule is take the outside derivative. So the outside function is the f. So f prime of g of x represents the outside derivative times the inside function derivative, so times g prime. So the next step, we have our formula here. Next step is to figure out what the exact slope is. So piece by piece, we're going to replace the x's with 1. And now we're going to use our table to help us convert these eventually to a numeric answer. So first thing, I'm going to work from the inside out. So g of 1 is asking for the y value of the g graph when x equals 1. So g of 1 is 3. I'm going to replace g of 1 with 3. So instead of f prime of g of 1, it's now f prime of 3 times g prime of 1. So now this becomes more straightforward because f prime of 3 we can just pull from the table. G prime of 1 we can also pull from the table. So f prime of 3 is equal to 4. Okay? And then g prime of 1 is equal to negative 3. 4 times negative 3 is negative 12. 63, this is another chain rule problem, but the format is a little bit different. But we need to recognize this as a function within a function. The x cubed is inside this larger function of f of x. So again, chain rule, outside's derivative. So outside's function is f. So f prime of x cubed is going to be what represents the outside's derivative times the inside's derivative. So x cubed becomes 3x squared. So now we're going to replace every x with 1 because we're asked to find p prime of 1. Replace the x with 1, so x cubed becomes 1 cubed becomes 1, and then this becomes 3. So this is f prime of 1 is still in the function notation, so we can use the table to help us get to that numeric answer. F prime of 1. So f prime of 1 is going to be 2. And then we're replacing f prime of 1 with 2. 2 times 3 is 6, so p prime of 1 is equal to 6. 68, a differentiable function is shown. So differentiable just means a smooth curve, no breaks, no sharp turns. Estimate f prime of 1.5, so we're asked to estimate the exact steepness of 1.5. Now at 1.5, we don't know the exact steepness, we don't have f prime, we can't plug into a derivative function. So the best that we can do is use the closest points from our target x value and then just find the slope, because slope and derivative are related. They're both going to give us information about the rate of change. So to find our slope, we do change in y over change in x. So 14 minus 10, that's going to be our change in y value, divided by the change in x, 1.4 minus 1.2. I'm sorry, we're asked to find f prime of 1.5, so I need to be using these two order pairs. So 22 minus 14 is the change in y, and then change in x is 1.6 minus 1.4. We get 8 over 0.2, which reduces to be 8 over 1/5, which is 8 times 5, which is 40. For 85, we have to understand that relationship between a function and its inverse. And that relationship is that a function and its inverse are always going to have flip-flopped order pairs. They're always going to have corresponding points. So if order pair 1, 2 is on one function, then on the inverse there must be 2, 1. All right? And at their corresponding points, there's also a relationship numerically with their slopes. The steepness at their corresponding points will always be reciprocals of each other. So if one slope of a function is 3, then the other is going to be 1/3. If the slope is 5, then the other is going to be 1/5. But let's look at what this tells us here. We're asked to find h prime of -1, so we have to understand that this -1 is the x value of the h function, but it's really the y value of the f function. Okay, so that's what we have to understand. They don't give us the x value directly. We have to find that ourselves. So we know -1 is the y value of the original function. So if I set f of x equal to -1, I can kind of work backwards to figure out what the x value is. And if I get 2x cubed minus 3x plus 1, if it's not factorable, go through a series of guess and check numbers around 0. It should be easy to find. In this case, if I plug 1 in, I'm able to get this to work. So 2 minus 3 is -1 plus 1 is 0. We know positive 1 is a appropriate x value for our function. So that's what we found just by kind of guessing and checking. So now that I have the x value for f, I can use this to help me figure out the slope of this f graph. So the slope is going to be the derivative first, though. So f prime is 6x squared minus 3. I'm going to find the slope of the f graph. Plug 1 in for x, I get 6 minus 3, which is 3. Now, if the slope of the f graph is 3, then the h graph is going to have a reciprocal at its corresponding point. So if f is 3, then we know h, the slope will be 1/3. Right, 86, same idea, just a more condensed form here. We're trying to find the inverse of f, the slope of the inverse of f at 2. So we know that 2 is really the x value, 2 is really the y value of my f function, my original f function. So if I know that 2 is the y value of my f function, then let's see if any of these order pairs will match with what we know to be true. Well, we know f of 1 equals 2, and that matches what we know, right? When y is 2, or x is 1. So now that I have this x value for f, I can find the slope of the f graph. And if I know what the slope of the f graph is at 1, then I know what the slope of the inverse is at 2. So f prime of 1, they tell us, is 3. So f prime of 1 is 3, so the derivative of f inverse at 2 is going to be 1/3. Looks like we didn't need this f prime of 2. So this f prime of 2 is just there to throw students off and just to ensure that students understand what pieces they need and what pieces they don't. Okay, so we don't use this f prime of 2 equals 4. It doesn't fit into any of our categories. All right, last problem here. At what point on the interval does the function satisfy the mean value theorem? So mean value theorem states that if we're dealing with a smooth curve, the slope between the endpoints, so here's the slope between the endpoints, can be found at least once on the interval between the endpoints. So if this is a slope of, let's say, 1/2, then there must be at least one more slope of 1/2 on this interval. But if we look, it's asking how many points actually share this average slope on the curve. So on the curve, can we guarantee one or more? So based off of what we see here, we see the graph is going to eventually hit that average slope once here, another time here, and a third time there. So just by kind of looking at the graph and trying to picture what the steepness is at these corresponding points, we see that there's going to be 3 points that's going to satisfy mean value theorem because we're able to see the graph in front of us. Now, if we couldn't see the graph in front of us and we know it's a smooth curve, then we can guarantee at least one. But because we have the graph in front of us, we can visualize that we see 3 points where there's going to be a slope that is parallel to this one here. So that's our answer choice D.